Hi everyone. Today I'm going to be showing you how to use a naive Bayes classifier to do sentiment analysis. So sentiment analysis is exactly what it says. It's We're going to analyze how happy or how sad someone is, or their sentiment, their feelings about a topic. How are we going to do that? Well, I found this data set on the internet. It's not too large. And what this is a list of book reviews and movie reviews. And what you'll see for example, here's an example that says, I like the Da Vinci Code a lot. That's a positive review. And they've labeled it for us. Here's a 1. And so there's about 7,000 of these examples in our data set, and we're going to go through and look at all of them. They're going to have ones and zeros, and we're going to use those labels and the text review, to train a classifier to help us understand a positive review versus a negative review. Hopefully that makes sense, but if not, you'll probably get it when you start following along with my example. Okay, so here we go. In this first cell here, these are all the imports of things that I'm going to be using. You've seen all this before. I'm going to be using pandas to read the file. Keep in mind, this is a little bit different than what we've seen before. This isn't comma separated. This is actually tab separated. And so I've thrown in this extra parameter here, sep equals \t. And what that does is that says use \t as the separator between variables. And then lastly, I've thrown in names for our two columns because there isn't a header in this one. So I'll run that, and I'll show you just the top of that. And here we have our very first 5 reviews. So you see that each one of them is in the liked category 1, which means these are all positive reviews. The negatives come at the bottom, which sometimes we would need to shuffle those up for some machine learners, but not for naive Bayes. Okay, so in the text, we can see that the text of these is the actual review that the user typed. I liked the Da Vinci Code a lot. The Da Vinci Code book is just awesome. All right, so what we're going to do is we're going to vectorize this text, turn it into numbers using TF-IDF, just like we did in the LSA lab. And then what we're going to do is we're going to take this liked variable, and this is going to become our dependent variable, and we're going to train a naive Bayes classifier to predict either 1 or 0, meaning the person liked it or didn't like something, based on the text. All right, so to do the TF-IDF portion, I'm going to use this exact same code from the LSA lab. It's really not changed, except I'm using just plain old stop words. I don't have to add a lot to my stop words. My text is pretty clean in this case. All right. I have my vectorizer instantiated and ready to go. I can say that y is going to be equal to the data frame .liked, which is this column. So I've set up our dependent variable. And then I will take df.text, which is going to become an array of our independent variables, the vectorized text. I'm going to run tf-idf on them, and I'm going to return the results to that back to x. So that's done. It was very fast. And we can see here that we have 6,918 observations and 2,022 unique words that are going to be stored in a sparse matrix. And you probably remember all of that from the LSA lab. Okay, so like always, to understand how good my model is, I'm going to do a test and train split. So I'm going to use a 20% holdout. That's done. Okay, and now I'm going to train up my naive Bayes classifier. The great thing about naive Bayes is that it's really fast and it only needs one pass over the data. The other really great thing about naive Bayes is it's not affected at all by sparse data. So most of these 2,022 words don't occur in a single observation, and that's okay. Naive Bayes doesn't care. All right, so we'll run that. We see that it's been fit. It was that fast. So let's see how accurate it is. And to do that, I'm going to call our old friend rock AUC score. And I'm going to compare y test versus the prediction on x test class 1. We'll do that. 0.9979. So we can say that that's a pretty darn good model. Great. All of this probably looks very familiar. So I'm not going to spend a lot of time on this, but I wanted to show you a naive Bayes classifier and how you could possibly use it. Text classification is the perfect way to use naive Bayes. One last thing, I figured I would show you how you could use it on a new example. So I created a movie review here. Notice I had to put it inside of an array, and that's because we trained it on an array, so that's going to help us get our shapes lined up. So I created a movie review that was not in our data set. I said Jupiter Ascending was a disappointing and terrible movie. And if you've seen it, you would probably agree with me. Okay, what I'm going to do is I'm going to take that array of text, I'm going to run it through the transform, not fit transform, but only transform because it's already been fit, of our vectorizer, and I'm going to get the TF-IDF results of only this variable, or of only this movie review. And then I'm going to call our naive Bayes predict function on that vector. And so when I run that, you'll see that I get an output of 0, which means that naive Bayes does agree with me and believes that my sentiment is that Jupiter Ascends is a terrible movie. Okay, I hope that was fun. I hope you liked that, and thanks for listening. Bye.